Hi, today I'm going to be teaching you how to do level 3 thermochemical principles Hess's law questions. This is from 2021. So Hess's law, in every Hess's law question, you're trying to find this equation using this data, and then you're trying to find the standard enthalpy change from this data. And whatever you do here, you gotta do here as well, and you'll see what I mean by that in a second. So what I always do is I always look at the first thing in this equation, and then you look at the molecule you need, which in this case is NH3G. So you look at your data and you find an equation with NH3G in it, and then you'll realize that that it's in here. But you also need to realize you need 4 NH3s. But this only has 2 NH3. So what you can do is you can multiply this equation by 2. This entire equation by 2, which includes the enthalpy change. And once you do that, you can just copy it down. This is just the coefficients, by the way, so it would be like this. And now we have that. So now we look at the second thing in the equation. We need O2 and gas, and then now this is when you have to be careful, and there will be a lot of trial and error in your answer when you're doing this in the exam, probably when you realize, oh, that doesn't work because blah blah blah. But for this question, okay, so the reason why I say that is because there are 2 O2 gases in 2 different equations, and you may be wondering, well, which one do I use? I would say go with this one overall, just looking at like how this NOG is on this side, and then this NOG in this equation is also on that side. So I would go ahead and multiply this. I would multiply this by 2, because if you multiply this by 5 to get that, this wouldn't be able to cancel out. I mean, wouldn't be able to disappear, and it also wouldn't be able to add onto that without becoming 11 O2. And that's not what we want. So not 11 O2, I meant 6 O2, because like 5 plus 1 is 6. So you look at the NO2 in this case. If you realize that there are 2 O2s in 2 equations, and you don't know which one to use, always look at what else is left in the equation. So now we can go ahead and multiply this by 2 to get 4 NO2 and 3 O2s. Okay, so now that we have this, now we can see what we do with the final equation. And we can look at what else we need from the equation. And we can do like an easy one. So like since we already have O2 in this equation, we don't need to look at the O2 in this equation. And the H2 is kind of hard to tell because it's not in this equation. So the last thing, the easiest thing to look for in this equation would be H2O because it's in this equation. So now you can see that you can get H2O from this equation. However, it's on the left-hand side. This is on the left-hand side, and this is on the right-hand side. Everything on the left side of the arrow is on the left-hand side. So we can actually get this to the right-hand side by reversing the equation. So I'll just write like reverse. And once you reverse the equation, you can do this in multiple steps. So I'll just reverse this now. And to reverse something, you just like keep it the same, but put this to the left, and this to the right, and this like comes after this one, so this still comes after this one. Now that we have it reversed, at least we have. Wait, what is this? Sorry, I forgot to add that. Now we have H2O on the right-hand side, which is what we want. And now, oh, by the way, when you reverse an equation, you change the sign of it. So this was a positive, and now you make it negative. Now, because you're trying to get this, you do the same thing earlier. You multiply this number by 3, this equation by 3, and then you multiply this by 3 as well. So this would just become this. And that's essentially it, because for trying to get what you want, without elimination or subtraction, if that makes sense. Like, we have this now. And now we have to get rid of, wait, what am I doing? You have to get rid of, like, wait, I'm just going to look that up because it's, like, distracting. We have to get rid of the ones we don't need, the ones that aren't in the equation. So in this case, we don't need H2 because it's not in the equation. We don't need N2 because it's not in the equation. We need O2, though, and we don't need this. So to get rid of something, you just, if they're on opposite sides of the equation, like for example, this is on the right hand side, this is on the left hand side, you can cancel them out. Okay, I can't actually cancel that out with that because they're not the same thing. You can cancel this one out with this because this is on the right hand side and this is on the left hand side. So let's do that. So this is gone by you, and this is also gone because this is on the right hand side, this is on the left hand side. So that's gone. And now what's left to do is we can add these two together because they're on the same side. If they're on the same side, you can add them together. If they're on the opposite side, you can eliminate them. So we can copy everything else down like you do in like an algorithm, if that makes sense. Like, you know, like 11 plus 11, 22, because you do that. It's basically that now, because you just collect together the like terms and copy what's left. So once that is done, we have the equation now. So now that we have the equation, we can find the enthalpy change by literally copying this whole thing down. Like, you literally just write like whatever equals 92 times 2 minus, that's a minus there, 572 times 3 plus 180 times 2. Like, you literally just copy this thing down, like with the plus and minuses, and then you put this in your calculator and you get the answer. I can't be bothered to put in my calculator, but I know it's right because I'll look at the answers. Okay, here, like, so, okay, I'm, like, pretty sure that's right, because they did the same thing as me, and they should get, like, that's the unit, and I know that because it's the same unit for these, so that you keep the unit the same. And then that's literally the answer, and if you want it just 3 significant figures, you just make it into 3 significant figures. Okay, done, bye.